So just like long division, synthetic division is going to make sure that you write things in the right order, is very important, and you include zeros if anything's missing. Now, in this question, all of the things are already written in the correct order, and no term is missing. It's not missing an x cubed or an x squared. So for setting up our synthetic division, we write the coefficients. So we start with -3, 2x cubes, 3x squareds, minus 4x's, and 5 is our constant. Outside of this sort of box, we write what we're dividing by. We're dividing by x plus 2, so we always change that sign and write, in this case, it'll be -2 instead of +2. Now, synthetic division for us is only going to work when we're dividing by things that are x plus or minus something. I'll put k. So if you're dividing by 2x plus 3, or x squared plus 7, or anything different than just x plus or minus something, you're going to have to use long division. I mean, there are synthetic division special rules for those cases where you could use synthetic division, divide by 2x plus 3. But for us and what we're doing, we're only going to learn how to use synthetic division when you're dividing by something that's in this form. So now that we've set up synthetic division by writing the coefficients and changing the sign, the steps are as follows. You always bring down your first number. Then with that first number, you multiply it by the -2 that's out front. So this -2 here gets multiplied, and you will get +6 there. And then we add. 2 plus 6 is 8. This step repeats itself over and over again. Now that we've got the 8, the -2 gets multiplied by the 8. That gives us -16. And we add to get -13. Now that -2 gets multiplied by that -13. That'll give us +26, and we add to get +22. And finally, that -2 gets multiplied by that 22 to give us -44, add, and we get -39. So we can now write our division statement. That was our Dairy Queen statement. So our polynomial that we started with was -3x to the 4 plus 2x cubed plus 3x squared minus 4x plus 5. It's going to equal our divisor. We were dividing by x plus 2, multiplied by our quotient, and our quotient is going to be this part of our synthetic division. The very last number in the synthetic division is always your remainder. So we're going to write these out. Now we have to add the variables and the powers with them. One thing you're going to notice is that it's always going to start with 1 less, a degree 1 less than what your polynomial was. So our polynomial, we would say this is degree 4 because its highest power is a 4 in the x to the 4. So we'll start with 1 less, and then we have -3x cubed plus 8x squared minus 13x plus 22. That's your quotient, and then your remainder is a -39, so we subtract 39 at the end. So our synthetic division, in a lot of ways, is nicer than long division. It doesn't take as much space, it's much faster to write out, gets our answer very quickly, but it's nice to see, like the example that we did, to see where those numbers come from and how it works. So if you look at what long division is happening and you do a synthetic division at the same time, you can sort of see why do these numbers work out the way that they do. Questions you can do for practice, and we are going to practice this a little bit because synthetic division and long division is sort of the basis for this whole unit, are 8, 9, 11, and 12.